Hi, I'm Dr. Padilla. In this video series, we talk about creating data visualizations in Vega-Lite. And now we're going to talk about encodings. Encodings are the visual attributes that you can apply to your data visualizations. It will allow you to add more meaning, but also allow you to express your creativity. So let's jump in. Now I have an observable notebook here, and what I've already done is I've imported Vega-Lite, and I've also imported this data set here. So I'll let you pause the video and go ahead and type that code out to get up to speed on this visualization. Now, the actual data set that I have is from NASA, and what it is global temperature abnormalities throughout the entire time range that the data was collected for this information. There's some more information about the citations here and how this example was based on this great work by this individual here. So what you'll want to do is to make sure you have this CSV loaded, and I will link this data in the description so you can upload your CSV. And what we're actually going to focus on today are the different encoding channels. Now, there's a whole range of encoding channels that we're going to cover, including position, which is the X and Y values, size, the size of the marks, color, opacity, shape, adding a tooltip, which is pretty fun, ordering the information, and then separating out the data into columns and rows. Let's start with the first visualization here. So we'll do VL and we'll start with a point mark. Scroll up a little. And the data that we'll specify this as is the AB temp. That's what I named that data set. And then we need to add our first encoding. And I'll start with just a X value, and I will set the field to be quantitative. And the field we'll actually visualize will be this temperature abnormality value. Now, after you've done that, then at the end, what you want to do is make sure you specify to render it. Let's change that to data. There we go. And what we have here is a point plot that illustrates the different abnormal temperatures in this entire data set. Now, this is sort of interesting. We have this horizontal orientation, but all the dots are stacked up on themselves. You can't see the depth of the dots, and we're really just missing a lot of key information here. But this is what we would call a horizontal positional encoding, what we have. We can also do it vertically by changing the X to Y, and now it is vertical here. Now, I just want to say that there are different reasons that you might want to put your variables on the X and Y axes. The traditional knowledge is that your quantitative values go on the Y and categorical variables go on the X. I think that's a little bit outdated, in part because modern research on visual perception indicates that we have a more fine-grained ability to detect differences in horizontal position than vertical position. So if your quantity is shown horizontally, that is a little bit easier for our optical neurons to pick up on. So I think there's more flexibility there. But I would say that what you want to do is to map the values onto an appropriate metaphor. Temperature rises, right? High temperatures rise. So it makes a lot of sense to put temperature on the y-axis like this. Time, we often think of going from left to right. So it makes sense to put it on the x-axis. And that's actually what we're going to add. We are going to add time onto the x-axis. So let's go ahead and do that. VL.x and add it as a field, make it a time variable, and that is here. Okay, so really with just some simple code, we already have a visualization that's fairly informative. It's showing us that abnormally high temperatures are happening in these later years, and abnormally lower temperatures were historically recorded from about before 1960, which is fascinating. So we want to now look at some different encodings that we can add to this to change the aesthetics, change the meaning, try to help people understand it more easily. The first thing we'll try is to change the size. So what we can do in our grammar of graphic style is to add specificity to our graph by simply adding another line, and we'll do VL.size, and then the field is going to be quantitative, as we are going to take this temperature abnormality value. Okay, so what we have done now is we have mapped the temperature normality to size, with the lower values, the more colder temperatures being smaller and the hotter temperatures being larger. Now that mapping doesn't make a lot of sense, mapping physical size to temperature abnormality, but I just wanted to show you what the technique would look like and how we would go about adding it in Vega-Lite. What I do want to do is to add some opacity to this so we can start to see the differences in the dots. Again, we're adding more specificity here, and I've just made all of these dots a slightly lower opacity of 0.3. And this is how you'll start to see the depth of different points or different elements, because the way that these graphics programs work is they stack up this information. So if there's a solid object in front of another object, you will not be able to see it unless it's more opaque and you can kind of see through it. Essentially. So that's what we're doing here. Okay, the other thing I'll do to make this a little bit easier to see is I'm going to change the width of the overall plot, and I'm going to make this 600. And this is just going to spread it out a little bit more so that we can see the individual points a little bit more easily. I do want to note, instead of just having a fixed value like 3, we can actually map opacity to an attribute. So for example, we could map it to this temperature abnormality. So all we would really have to do is like this. And all of a sudden, we're changing the opacity of these individual circles here. Still a little hard to see, so I'm going to go ahead and fill in these circles. Now it's interesting because when it's done like this, it's actually quite hard to tell if these different opacities are opacities or different colors. For us, they just appear to be light blue to dark blue, and you can sort of see them, you know, grouped up more here, but it is, from a viewer's perspective, it could be confusing to know if this is opacity or color. So you have to be very careful when, you know, manipulating both. So I do want to go ahead and add in color now, and I'm going to change this opacity field back. I'm going to make it 0.5. It's uniform. I'm going to change it back. I'm going to make it uniform 0.5, and then we would need change it back to a value. There we go. And now I want to go ahead and add color. This is going to be field quantitative. And again, we'll take this value and plot it here. So we have color going from light blue to dark blue. And this is actually, I think, becoming a little bit more informative, where we're starting to see this kind of impact where these more recent times have these higher temperatures. The color is kind of emphasizing that point a little bit, which is good. But what I want to do is select a color palette that magnifies the difference between these negative values and positive values to really emphasize the main message that I think is in this plot. So what I'm going to do is I'm going to change the color from just the default that's provided here, which is a continuous color encoding, to a diverging color scale. Diverging color scales go from one value to another with the center point. So the diverging color scale that I'm going to use, I'll add it like this, where we'll just add it on the end. Scale, and we're going to need to specify a range. And the range will need to be diverging. There we go. Now this diverging color scale is the default one. It goes from kind of orange to blue, and this is pretty good. We're already starting to emphasize the points that I'm trying to draw. But I do want to say with this color scale, one of the issues is by default, it takes the range of the data and it picks the center point of the data to make this kind of neutral value. In our particular data set, 0 is a really meaningful neutral value. So rather than having the light color kind of in the center here, I would like it to be more at 0, because what this is reflecting to me, if I wasn't reading it very carefully, is that there's a whole lot of this orange and some blue. And if I wasn't reading it carefully, I would assume that the orange are, you know, these lower values and the blue is higher values. So I might come to the wrong conclusion that there aren't that many abnormally high values in this data set, which is incorrect. So I'm going to change this color palette to one that I defined in advance. Okay, feel free to pause the video and copy over this code. What this particular scale does is it uses specific individual values and it associates a color with each of those. And the way I arranged it is so that there is a clear distinction between these negative values and these positive values, which I think more clearly communicates the message of this particular visualization. Now, there is a lot more to say on color. We'll have a whole series on color, but suffice to say that color is one of the easier things to mess up, and one of the things you're going to have to be very careful in using. So use it cautiously. The next thing I want to add is shape. Shape isn't going to help us a lot in this case, but I want to show you how to do it. So we'll do VL.shape, and the field is going to be nominal in this case, and we'll add month. You know, we could have treated month differently rather than nominal. I just wanted to show you how it would apply these different individual shapes to the different months. So that might be meaningful. I find shape to be sort of tricky generally, but you might end up using it for various reasons. Okay, I'm going to take that off. Now the next thing that I'm going to add is actually pretty cool. And what it is a tooltip. So the way that a tooltip works is based on the value that you are having it represent. It is going to give you a hover over over effect for that value. So this is going to be a really useful way to do that month data. Nothing changed except when you hover over these points, you start to get the value for the month. And this can be very useful if you're doing some data exploration. You might want to know what these high months are. This one's March. What these lower months are, January, December, for example. So that's a pretty cool, little easy interactive technique you can use. Now, the last thing that I'm going to talk about is separating these values onto individual plots. Right now, the months are all stacked up on each other. Maybe we want to look at individual months. So one way that we can do that is we can add column, vl.column, and that field will do for the month as well. Now what's going on here is it broke out all of the data into individual months, which is useful. And I'm actually going to change both the width and the height so it's easier for us to see. Okay, so we have the different months here. This could allow you to scroll through this and determine if there are any specific months that have a bigger spread that might be of interest to you. Looks like February a little bit, maybe March you're seeing these really high temperatures. People who know more about global temperatures might be able to interpret that. But this can be a very, very useful technique, and you can do the same thing for a row if you wanted to go vertical like this. Now, something you might have noticed as we did this, go back to columns, you can see, is that these aren't ordered in any sensible way. Well, they're ordered based on alphabetical ordering. You might want to order them differently. That might help people interpret your data successfully. So what we can do is add a sort to this. Have one set up where essentially all we're doing is sorting the individual months. And there's a lot to say about sorting as well. It's a very useful visualization technique. I simply just order these based on proper monthly organization. So that concludes our overview of encodings. I hope you found this to be a useful exercise in decision making in terms of which encodings to use, why you might want to change encodings, and how to ensure that your visualization is as expressive as possible, meaning that it's expressing all of the elements of the data and only the elements of the data. Beyond that, you should use that as your primary goal, but beyond that, you can do creative, interactive, engaging things with different encodings.